Hello and welcome to Newton's Bench again. My name is Greg Perugini and today's lab is on projectile motion. Projectile motion is simply kinematics in two dimensions. We launch something and it has a velocity in a y direction and in the x direction. And these equations apply separately and independently in each dimension. So let's say in our experiment we want to find the speed that a marble leaves the launcher as well as the marble's maximum height and flight time. How do we do that? Well, looking at these equations, first we have to figure out what we know. When I launch a marble, let's do that right now. And you'll use this launcher. We can launch it and we can measure the distance of the launch, how far it went, right, in millimeters. We'd have that measurement. We can get this angle that it's launched at using a protractor. Distance in the y direction, well, we don't have to worry about that, it's level. There's no velocity in the x direction because, of course, once it's launched, it's going to keep going in that, assuming there's no air resistance to speak of, we will not have any deceleration. Of course, through the entire parabola, we have acceleration due to gravity, negative 9.8 meters per second squared. Okay? So, with no acceleration and no velocity in the x direction, in both directions, we're missing two variables in all the equations. Well, if time is the same in both directions, the time it took to go in the y and the time it took to go in the x and the time it went in the y, then we can solve using simultaneous equations. Looking at this third equation, so given there's no acceleration, this part goes away. We've measured the distance it went. We don't know the velocity initial, but whatever the velocity initial is, it's velocity initial times cosine of the angle. So given the distance, I can solve for time. And you see that time is equal to the distance the displacement of the marble in the x direction, divided by the velocity in the x direction, velocity initial times cosine of the angle. So I have that one piece for time. As I said, time is the same in both directions. I can plug that in here and have velocity initial in the y direction as being velocity initial times sine of the angle. And I know that I did not go any distance in the y direction, so that would go to 0. So, in summary, velocity initial in the y direction is the velocity initial times sine of the angle. We can get that here. As I said, it went no displacement, so I can use this equation in the y direction, knowing 0.866 velocity initial. I can plug in here. I can plug in the time from the x equation in both this part here as well as in this part here. Well, putting it all together, I have only one variable here, velocity initial. If you solve this, you should get velocity initial is 15.04 meters per second squared. That is the velocity in my example here. Not the example, of course, in launching this, but the example that I put together, launching something at 60 degrees and it going 20 meters. You obviously are not going to get a launch of 20 meters, and this is not 60 degrees. You would use your protractor to measure that. From this point, you have the time and you have the velocity initial and velocity initial in each direction. It should be relatively easy for you to come up with the time of the flight, how long it took to make that flight, and the maximum height. And the maximum height in the y direction is more or less like a free fall equation. The velocity in final is 0. It's at the top. It's not, doesn't have a velocity. And t would be half the time it took to do the complete parabola. So, with just measuring the distance and the angle, you should be able to tell me the initial velocity of the marble, its maximum height, and the total flight time. In my example on the previous slide, I didn't calculate the maximum height or the flight time, but you'll be asked that in the OLARs. Make sure you fill out the methodology section completely. Needs to be detailed. Again, assume the grader knows nothing about the experiment, and don't forget a picture or two. Make sure you show all your work, and good luck.